All right, let's take a look here. For time greater than 0, the velocity of a particle moving along the x-axis is given by v of t equals these two factors. At what time is the acceleration of the particle equal to 0? So for acceleration, we've got to be thinking second derivative. A couple options. We could do the multiplication, or I think we could try the product rule. Probably not a bad idea. And we have velocity, so we just need one derivative for acceleration. So v prime of t is, the derivative of the first is 1 times the second plus the first times the derivative of the second. T minus 2 there. And chain rule there just brings in a 1, so. And then we can probably do a little simplification. T squared minus 4t plus 4. And then over here, t squared minus 7t plus 10. So 2t squared, 3t squared, minus 18t plus 24. All right, let's factor out the 3. A little algebra test here. T squared minus 6t plus 8, which is t minus 4, t minus 2. So the 4 and the 2 are what we're considering, but then we have to decide if it changes. So let's check the 2 and check the 4. If I put a number in like 0, I get a negative number times a negative number, which is a positive number. If I put in 3, I get a negative positive, which is a negative. And if I put in a 5, I get positive positive. So it does change at both. It changes from concave up to concave down, 2, and it changes from concave down to concave up at 4. So it does change at both of those, but we should check to make sure it changed. All right. The cost in dollars to shred the confidential documents of a company is modeled by C. So C is cost. A differentiable function of the weight of documents in pounds. Of the following, which is the best interpretation of C prime of 500? So the derivative of C. C is a differentiable function of the weight of the documents. C is the weight of the documents. What is the derivative of C? So the cost to shred 500 pounds is $80. I would say C of 500 equals 80 would be the cost to shred, because that's just the weight. The average cost is 80 divided by 500. Definitely not that. Increasing the weight of the documents by 500 pounds will increase the cost to shred. No, I would say we're not increasing. I'd say we're at 500. So I mean, this one seems pretty cut and dry. The cost to shred the documents is increasing at a rate of $80 per pound when the weight of the documents is 500 pounds. So saying the cost is increasing, meaning its derivative, is 80. Its derivative, it has a rate of 80 at 500. I think that's the one. All right, we've got a piecewise function here in 9. F of x equals x for x less than 2, and 3 when it's greater than 2. So what does that graph look like? That's an easy one to graph. Here's 2, y equals x, and then 3. If f is the function defined above, then the integral from -1 to 4 is, all right, so we just got some area to find. This area, 1, 1, is going to have an area of a half negative. This one is 2, 2. So it's going to have an area of +2. And then we're going to 4. So this is 2, 3, 4. So then this has got an area of 4 times 2, 8. 8 plus 2 is 10, minus a half is... Oh, that's not there. That's because this is 2 times 3, which is 6, which is 8. Minus a half is 7 and a half, which is 15 halves. A little multiplication mistake there. All right, and we've got an integral of e to the x times the cosine of e to the x plus 1. So we've got to do a little u. U is whatever's inside, e to the x plus 1. Du is e to the x, which is convenient. So then I've got the integral of cosine u du, which is just going to be sine u plus c. So my answer should just be, I believe it's just going to be A. There it is. That was a quick U substitution.